and I have with me today Chris Bettinger with Oldcastle. Chris is one of the best top salesman specification writers I have ever come in contact with, and we really appreciate him with the Masonry Association, and we're glad he is with us today. And
I just asked him not to do that. So thank you, Don. I appreciate that a great deal.
Yeah, I also asked him not to swear, so
I asked him just to say the best things in sliced bread, but no, he had to go through all that. So.
And we are very happy to have with us today Dan McKrill, and he is with FBR, and he is got a piece of equipment that does something pretty spectacular. I think associated with this podcast, Deb will probably put in some video of your equipment so people can watch the podcast and then see what it's like. So FBR doesn't tell us much about what we're going to talk about. So Dan, I'd like for you to sort of, take a few minutes, tell us about FBR, tell us about the Hadrian piece of equipment, and where we're going with this.
Yeah, sure. Thanks, Don. Thanks for having me. So FBR. So FBR stands for Fast Brick Robotics. We're a robotics company based in Perth, Western Australia. I'm currently over here working with Oldcastle and a whole bunch of additional companies on trying to introduce Hadrian X, which is our first robotic block mason, into the American construction market. Hadrian X basically has an end-to-end delivery system. So what we do is we have a forklift on site where we load full pallets of blocks into the back of the machine. From there we have a dehacker robot which we deassemble or unstack the pellets and put them onto a slice of blocks onto a shelf into the back of Hadrian X. And then from that point, we kind of individually pick them off the shelf and send them to where they're located in the build. So in the back of the truck, we have the ability to cut the blocks where we do need a cut block, because we all know that a structure never finishes on a full block or a half. So we have the ability to cut the blocks in the machine itself. And then it basically makes its way through the carousel and then up through the boom to the delivery system, and then it gets placed in its position in the build. So each block has an ID or a reference number, so we can easily identify each block and name each block and give it a location into the build. And we kind of, instead of using, say, a traditional mortar, we use a construction adhesive. So that's a way that we're able to speed the whole process up and control the timing of the build.
So let me sort of go back and do some detail. Obviously, I've seen the videos, and so I just want to encourage everyone who's watching this is make sure that you that after you watch this podcast or before you watch the podcast is take a look at the video to see what this piece of machinery looks like, because it's otherwise you really don't get the feel for it. But a piece of equipment that does what you're talking about doesn't, it's not like you guys just like went in your garage and threw a few pieces of metal together and bolted it and came up with it. How long has this been in the development process?
Okay, so this has been a long time in the process. So it goes back before I started working there originally. And I've been with the company since 2011. Probably about 5 years ago, or estimate about 5 years ago now, we launched onto the Australian Stock Exchange. Kind of raised enough money to keep us going and to develop the first prototype machines that we're currently running in the Australian market at the moment. And that's been really beneficial. We've got, like I say, we've got 2 working machines, and just getting the option to use our machines while still trying to understand them in the market has been priceless. Generally, when you do have a prototype, it's such a big risk for any parties to allow you to work on their sites, but due to the economy and the building boom that we're currently going through in Australia at the moment, it's been a kind of a walk in the park. It's been probably a little bit too easy. So it's now we've got machines working. We're understanding how they're going to be established into the market. We're creating a maintenance program. So it's actually completely beneficial. So we're absolutely wrapped. So again, going back to the timing of the company, we've been going since 2011. So it's and prior to that, we've had a lot of hiccups in between that as the GFC hit. That was kind of our big and first nightmare. But then most recent to date has probably been the coronavirus.
The GFC. I'm not tracking with.
So back in, I think it was approximately 2007, the global financial crisis, where we started prior to that. And as you could imagine, being an R&D startup company, we survived solely on investment or investment into the company. So we were kind of ticking along, going really well. GFC hit, and we kind of just had to shut everything down.
So, and I just wanted that when you see the videos, you're building houses, and you're building buildings, and so this is not something where you're imagining that you could do this. Is that you're building, selling, people are living in homes and buildings that you put together.
100%, and it's kind of, you look at the progression of the builds that we've done today, and like from our very first build, being inside a warehouse, we kind of demonstrated the technology, went amazingly well, we were really proud of ourselves. But then the next step we took, we kind of went outside, and then we built a single leaf wall with a load bearing structure, and then that house has now been sold and people are living in it. Then from there we've gone to say a double leaf wall, and we kind of, every time we've taken on an additional project, we've always challenged ourselves and tried to step up the ante and make the machine better and better and learn from each build that we've done. So at the moment, the machine's working on a site at the moment where it's eight townhouses in a row, 3 common walls on a sloping block. So it's just just everything that you could kind of imagine that a real life environment for a machine would be, we're actually experiencing on a day-to-day basis now. So we've got the confidence to and we believe that we can pretty much build just about anything now. So we've learned a lot. We're up to about 30 homes that we've built now. So, and plus commercial also.
Chris, I'm one of the things that it really hurts me to say, but you're really forward thinking in your ideas about what's happening in the market. I mean, that's why you're one of Oldcastle's top salespeople.
Okay.
Not just a specification writer.
I know.
So how did you hook into this, and I guess what is?
It's essentially, there's a couple things. We have a very strong relationship with the AIA, and on a regular basis, we survey the AIA as far as what are the things holding them back on masonry. And surprisingly enough, it's not cost, it's availability of labor and labor issues. They want to make sure that they get a quality project in a timely fashion. So that has always been a hot button, and we're talking over 11 years, it's consistently been it.
I know, I've seen those surveys.
Yeah, and it really hits you right in the face.
When you go into the architectural offices, you're not going to get out of there without a discussion on labor.
So when Dan originally approached part of the Oldcastle family, a sister company up in the Carolinas, Adams, and when they approached Adams, they felt that it was a good idea to bring Florida into the mix because we're such a strong masonry market. So that's where I was exposed to it. And the things that struck me right away is this is a great answer to the labor issue. And it brings in a younger group of people because of the technology aspect. It's a little sexier, it's a little cooler, things like that. But it also doesn't throw away the experienced mason out there because they can learn the software. They can understand the mechanics of it. they can be there for quality control. And I think the one thing that masons need to recognize, and our industry needs to recognize, is the more confidence architects have, and a machine like this can breed that confidence, the more they're gonna specify, and it's gonna benefit everybody. And I think that's where the opportunity comes from this. There are some things that we're going through in terms of developing a block that fits best the machine. We need to complement the machine's performance. So we're doing a few different things to make it that much better and stronger, just by doing having the right material for the machine to basically utilize its abilities. And that's been fun going through that, but we've had great exposure with the AIA. We've already shown it to probably 300 architects, which is a great response. We've talked to a number of the large masons out there. We're at the MAF convention. We did a presentation, or Dan did a presentation earlier this morning that I think was very well received. I think there's a great niche for it. I really do. And when I'm at trade shows with architects, we stand there and say, hey, it's a masonry guy. No way. And it's like, yeah, come on over. And I've actually had someone say, oh yeah, pyramids, masonry. I got it. We're good. And they just sort of keep walking. And this is something, there's a lot to be said that we're that strong, that we've, been that good for that long as an industry with masonry. But there's also a lot to be said that, we've got a new technological advancement, something that's going to freshen it up, something that's going to be new, something that's really going to aid it. The production rates and things like that, Dan could get into that, and the performance abilities of the machine. I think it works very well. How it takes a blueprint, that's done in a typical BIM format, put it through their software so the machine can analyze it, and then it basically lays out the building. You've referenced it as 3D printing.
Yeah, definitely. Well, we're ultimately a 3D printer. Traditionally, I think there's a lot of 3D printers around at the moment where it really depends on, say, the product that you're running through the 3D printer. So whereas a lot of the new age 3D printers in construction are using concrete, so a wet mix. Whereas what kind of makes us unique and a step above, what I believe above from the other competitors, is that we're using a product that already exists. We're not looking to change a traditional house.
Right.
It's the house is
We're
the
not
house.
building it out of something else. We're building it out of block.
And blocks being tested today. Everyone would love to have a block house, but unfortunately, we just don't have the masons or the workforce to give everybody that ability. So where our machine comes into its own, I believe, is we're building a traditional house with a traditional product, and it doesn't have to change. It's just a lot more faster, accurate. We're a lot more environmentally friendly. With no water. It's and I think Chris brushed on the speed also previously. Is where our current machine is, we're kind of peaking out at about 200 and 220 blocks an hour currently at the moment. And we've got a new commercialised machine that we believe we're going to be nudging around 500 blocks an hour.
Yeah, now, the masons who are watching this podcast know what that means. Typically the production is going to be 200 to 300 block a day.
Correct.
For a mason. I think there's probably, there was the first question, a couple of questions in my mind was how does the machine, if you could just sort of briefly touch on the technology that allows a block, because when you see the video, it's really impressive that block goes exactly in the correct place. And so there is a technology that allows you to do that. I don't want you to give away all your secrets, but there certainly is there's a way that you all are allowing that to happen every time, every block.
Correct. So the technology that we're referring to is DST, so it's dynamic stability technology. And what that allows us to do is accurately place a block and forgive me for my metrics here, because if it's one thing
You
we've
can-
realised.
Yeah, it is not against the law to use the metric system
Okay,
in the
thank you.
United States. It's not the common system, but it's not, we don't like punishing.
Okay, thank you very much. So we have the ability to place a block within 1 millimetre at 22 metres. Now, that's amazing, because when you take out, you're in an outdoor environment and you can't control the weather. As you can imagine, you have gusts of wind, you've got rain coming in, you know, every environment is completely different. So having the ability to place a product or a block at 22 metres within 1 millimetre tolerance, it's pretty amazing. So that's how we do it, is through our DST technology.
So it's not just a mechanical measurement or something. It is somehow that the machine is gauging where that block is out in the world as it places it.
Exactly right.
Yeah, so basically, when they look at the video, the reach of the machine that they're seeing is about 90 feet, right?
Yeah, 22 metres at the moment. Yeah.
Approximately 90 feet, and it has the capabilities to take 48 pounds
Yep.
and place it out there.
Yep.
And then we're looking at a window of, what was it, 10 by 10 by I think 16 or 19 inches, as far as the block size that's on that.
Correct.
You're gonna see all sorts of goofy Australian measurements.
Yep.
But there's no reason that our block will not fit in there, a typical block you see.
A regular 8/8, your block can process a regular 8/8
Yes.
16 blocks.
So the dimensions Chris just brushed on is our current maximum capacity block that we can go. We can pretty much go anything less than that. So anything all the way up to the measurements Chris has just brushed on.
And then, now, maybe this is premature, but you have your next machine where that envelope or box that we can fit the block into is gonna get bigger.
Correct.
So that's gonna really compound it, because if we can come up with a block that we will be able to do a block that's twice the size of a current block. And the lay rates there, you would mention, are gonna be pushing 500 units.
Correct.
So not only is it's 500 units of that size, but that's equivalent to 2 current units. So now we're talking about 1,000 units worth of coverage. And from a design point of view, the longer the overlap strengthens the wall, and the less head joints and bed joints you have, it's just that much more stable in terms of moisture and things like that coming into it. So all these things keep compounding upon each other, and it's just a lot of good things.
Yeah, exactly right. So, and I think a way to kind of look at this also is, and I agree 100% with Chris, is when we talk about 500 blocks an hour, it's kind of the way you can really play with that and mix that up also is it doesn't have to be blocks, it can also be laying motions. So as we go further into the future, and with, say, working with the likes of Oldcastle and block suppliers, is we can start to create blocks which don't exist yet, because the restraints or the constraints that we've had in the past no longer exist. We've always made a block that a human can quite easily handle or manipulate and put into that wall. We're now going into an era where we're bringing a machine that's going to be able to tackle all those tasks. So the bigger, where I'm going with this is, we make the block bigger, and if you're making a block a bit larger and larger and larger, and you're still doing 500 movements an hour, all of a sudden that, your square foot coverage becomes astronomical.
Yeah, your production goes up and up. I don't think, as a structural engineer, one of the very first things that I was concerned about when Chris told me about the initiative and about your machine was the structural, because obviously our wind loads here in Florida. So, as a structural engineer for the Masonry Association, my brain sort of started going through all the disastrous hurricanes that I have had the opportunity to look at, and so I think that and I've actually obviously had the opportunity to go up to NCMA.
Correct.
And see some of the testing. So I guess I don't know, Chris or Dan. I mean, you both have been involved with making sure that the technology, that the structural review, the adequacy is there. Just give us a little bit of the overview of how you're doing that.
You want me to jump in because of
Yeah,
codes?
I think with the codes, Chris probably knows a bit more about the codes regarding Florida than myself, so I'll get Chris to...
First and foremost, when we met with folks at Miami-Dade, they got locked into the robot part of it. Oh, it's a robot, we gotta figure this out, the robot, for code purposes, really isn't relevant. What's relevant is we're gonna use all the best practices that are currently employed in the masonry industry to make the best wall system, and we're gonna make one change. We're eliminating mortar, and we're putting in an adhesive. Now, you referenced the NCMA, National Concrete Masonry Association testing. It's testing out roughly about 1.5 times the capacity or performance level of a mortar.
Yeah, and in truth in advertising is that I am involved in the technical development of the product. So and proud to be so, and got the opportunity so I can verify what it is that you're saying, because I will be involved in the final approval of that. But that's exactly that the adhesive does exceed what we expect for mortars.
So that adhesive creates another issue for us. When we're laying it out architecturally, they're working with the modular design is in nominal dimensions, so it's the length of the block plus one head joint, the height of the block plus a bed joint. The head joint is not a problem for us, that's fine in terms of how we place the material to maintain that. What we're having to deal with is the height. So what we're gonna do is we're actually producing a full 8-inch, but still nominal bed depth, nominal length. And that full 8-inch will keep us on coursing for header heights, all the typical and accepted standards for doors and windows and design. So we plug in adhesive, which has great performance values. Going an extra 3/8 of an inch to replace that mortar joint is not a problem. We have to grind and rectify the block so that it's square and you have parallel joints.
This is an important issue, is because we've had a lot of people come in with ideas about stacking, gluing block, but it has not worked because block are plus or minus, according to ASTM, plus or minus 1/8 of an inch. So why don't you just explain a little bit more about what it is that has to be done?
Basically, when you're stacking these up, you're only as good as the one you put, the one below it. So it starts out with the slab. The slab has to be to a 2 mil tolerance.
Correct.
Which they've had great success in Australia.
Yep.
And really, that's an issue that time can resolve.
Yep.
So there'll be a premium on slab cost, and slab cost labor, but it's nothing that the machine's efficiencies won't make up for, vastly make up for.
Yep. So
you're gonna start off with that material, you put it down there, and when you have it grounded and rectified, your bed joints are parallel. So all it's gonna do is mimic what's below it. So you're gonna keep going straight. So if you have that first piece laid down and it's plumb level and square, the second, the third, as you go up are gonna be that way, because we have a very consistent block. We have a consistent delivery method for the adhesive. It's basically, a thin coat. What's the thickness of the adhesive when it's all done?
it's 0.5 of a millimeter, so it's we reference it as 1 millimeter just to make reference that it's there, but ultimately it's a dry stacking system.
And the funny thing is, when we met with Miami-Dade, once we sort of got that out of the way, now I sort of passed off the part regarding the robots. The robot was very cool, okay, and it's very cool to look at. They grabbed onto that. They have really they can't be a proponent of us, but they've been very friendly to the conversation because they see the value out there. You look at the state initiative with the Building a Safer Florida that the AIA has adapted. All of our seminars are geared towards satisfying Building a Safer Florida program. The building commissioners and the building officials all over the state are very well aware of that. And they see this because once they see the value in it once we get by the issue of the adhesive, which right now we've got great testing and we're going to be submitting that. So we'll be over that issue. And they see it as a great opportunity because they recognize the labor issues.
Yeah.
And the safest wall system is a single or double wide masonry wall.
Yeah.
For all the elements that we've talked about, and seen firsthand, like you talked about with hurricanes. So it really comes down to Like I said, they can't be a proponent of us. They're still taking a very independent view, and they're doing a very thorough research of everything we're giving them. But they recognize the value. So, they're excited about this as much as we are. Once they see that it passes, they're gonna be very enthusiastic about it.
Right, yeah. I think probably one of the last things that I just wanted to bring up is that there will have to be, depending on the wall height, you can't just glue it together. There will be steel and board cells involved with the structure.
That goes back to those best practices.
Yeah,
Yeah.
of course. And I think what we need to make clear is we're not looking to change the way a structure is built in say Florida or a region. We're still adhering to say the standards and the laws and the engineering detail, but we're doing it a different way. We're automating the process. So we're not looking to change the entire process or to skip out on something. We still want to do it the exact same way that it's being done right now, but we just want to do it safer, accurately, faster, and more environmentally friendly.
Well, this is a really exciting project, and I'm happy to have you here for the podcast today, and so thank you for being here, and look forward to working with you in the future.
No, I look forward to it as well, Don. So thank you for having me.
Chris,
It's fun to have something. Yeah.